In this lesson, we're going to look at what happens to ionic compounds in water when they dissolve and how we describe them as electrolytes. Electrolytes are substances that produce ions when they dissolve in water. For example, if we have NaCl or table salt, when it dissolves in water, it forms Na plus and Cl minus ions, and as a result, that solution can conduct electricity because of the mobility of those ions. When we look at water, what we see is that water is in fact a very, very, very weak electrolyte, which means there are very few ions in pure water. Then why do we always have to get out of the pool during a storm? So pure water is a very poor conductor of electricity. However, most water isn't pure. In Kentucky, water tends to be pretty hard, which means we have a lot of magnesium and calcium compounds dissolved in the water. And these species are excellent conductors of electricity. We describe electrolytes in three different ways, the first of which is strong electrolytes. And these are compounds which dissociate completely in water. And we represent this in the reaction if we have KCl in the solid phase, going to form K plus in the aqueous phase, remember that means dissolved in water, plus Cl minus, also in the aqueous phase. So if we look at our solution, we see that it dissociates completely, and we're only going to have ions in solution. As a result, all those ions lend mobility to the charge in the solution. We light the bulb fully because that solution is an excellent conductor of electricity due to the presence of the ions. When we look at weak electrolytes, we see that they dissociate partially in water. Notice that we have a different looking arrow here, and we call this an equilibrium arrow. This indicates that the reaction is running in both directions. What we're using it for here is to represent that we don't see a complete breaking apart of that molecule. What we see in solution is that we have some molecules and some ions in the solution. There are some ions which can conduct electricity, but we see that it is a very low conductivity electricity because there are fewer ions than in the strong electrolyte. And as a result, we have a dimly lit bulb because there is not enough charge carriers in the solution. Non-electrolytes do not dissociate in water at all. In this example, we're looking at ethanol, and we see it goes from ethanol in the liquid phase, so pure liquid, to ethanol in water, where it's in the aqueous phase or dissolved in water. And all we have are molecules. They do not break apart in water, so only molecules are present. We see that the bulb does not light up because there are no ions to carry the charge from the negative to the positive plate. Electrolytes can be grouped into various categories: strong, weak, and non-electrolytes. We've already seen ionic compounds, and those are all strong electrolytes when dissolved in water. We'll also see that strong acids and strong bases are strong electrolytes, and we'll talk a little bit more about those and how we identify those later on. For weak electrolytes, we have weak acids and weak bases, and then we have water, which is a very weak electrolyte, and then molecular compounds, which are non-electrolytes.